Hi everyone. Today we will have a workshop on data collection from a sensor and storing those data to MQTT broker, and we will also look how we can use MQTT not only for data collection, but how we can use MQTT also for control of a device. For example, if we need to take action on device like a start engine, stop engine, change configuration, and so on. We will also look at the way how we can store this data from the sensor in Influx database, and also we will look at data visualization. In this workshop, we will work with a Wi-Fi sensor, which is using a microcontroller from Adafruit Feather M0, and also we will look how we can do similar thing with ESP8266 sensor. We will have a DHT and BME280. DHT can measure humidity and temperature. BME can do the same, but also it allows you to measure pressure. And collected data from a sensor we will store in a MQTT broker. As I mentioned, we will do some data visualization in Grafana. We will use also a little bit coding in. We will do a little bit coding in Node.js, which will be used like application reading data from MQTT broker and storing this data in Influx database. And Grafana will read data from Influx database for visualization of sensor data. Here you can see actually the infrastructure that we will build. We will have a few sensor nodes connected through Wi-Fi network to our MQTT broker. We will have that Node.js application to read data from broker and store data in Influx database, and later on we will do some visualization. Here you can see actually our microcontroller. It's Adafruit Feather M0. It's a variant with a Wi-Fi connection. We will use the DHT11 sensor. You can see also that there is a battery, because what we will do is that we will provide a status about a device, and as a part of this status will be, for example, the current capacity of the battery, for example, how many percentage of the battery left. You can see there also a LED diode, and that LED diode we will use for actually like a simulation of a remote control through MQTT. Basically, we will be able to use MQTT to control this LED, and it can be, for example, simulation of something like a start engine, stop engine, or we can actually try to, for example, change some settings by MQTT. You will see later on. Influx database, it's something what we used in our previous workshops with Laura. I think that I don't think probably go to in detail how Influx database works, but shortly it's a time series database which allow you to store some data like, for example, temperature, humidity. It's similar to SQL database. I mean, similar that you have there also something like a table. Here we call it a measurement. This table can be, for example, a temperature or a humidity, and this time series database, it's a quite a good way how to store a lot of data which we can use for data visualization. We can have there also something like a data retention, that, for example, data stored in particular measurement, which is something like a table in a SQL terminology. And this data retention, for example, say that if data are older than 30 days, I want to remove it, and so on. In Grafana, later on, we will see something like this, where we can see, some charts and do some visualization thing. But before we will look, at any code, and we will continue with some examples, or we will start actually with some examples. So a little bit about MQTT. MQTT, it's a protocol based on a publisher-subscriber concept, which allow you to send data to subscribers. The subscriber, it can be, for example, in our case, our MQTT Bridge, which received a data. Data to subscriber can be sent from a publisher, which is, for example, in our case, a sensor. And this concept, publisher-subscriber, allow us to send data from one device to target application. We can have something like a topic, and that topic represent a folder. It's not directly the folder, but we could imagine that as a folder where we store some data, and if there are data, so the subscribers get this data and can use it for other processing. MQTT is something what exists here for a very long time. It's quite often used for a real-time communication between devices and between backends, which, for example, are used to receive data from the sensors, or these backends, for example, can send back a command to a device, and in general, MQTT can help us to do, automatization and monitoring of our IoT infrastructure. On a server side, we need something like MQTT broker, as you can see here on this slide. So MQTT broker, it's something like a server which implements that MQTT protocol, and is ready to receive the data from clients. And if you look back at this slide, so the Wi-Fi node is like a publisher who is sending data to a MQTT broker. MQTT bridge here is a subscriber, and topic is the way how they can actually reach each other. In our application, we will use the three topics. One topic will be used for sending of data, like about humidity, temperature, and other metrics. The other topic will be about sending a device status, for example, the level of battery. We can use it to send, for example, the MAC address, or if a device is in a good condition, and so on. And we will have also one topic which is used, for example, for remote control of that Wi-Fi node. So it means that we can send from an application a command which MQTT broker will send back through topic to a Wi-Fi node, for example. We will share again all source code on GitHub, so you will be able after this workshop, download everything, try to compile the code, to connect your sensor to MQTT broker, and run, for example, or run a command back to a device and so on. So let's start at first with Arduino code, where we will go through I will try to explain how actually you can create Arduino code that will send data through MQTT to a broker, and what actually we need to do for implementation on Arduino side. So at first, what we will need to use in our code, it's a Wi-Fi library, which will allow us connect to access point, and through access point we can connect to internet, and through internet to MQTT broker. We are using Wi-Fi 101 library, which is quite common for easy communication and for easy access of the network. We will also need to use a library for communication with MQTT. There is a quite known and quite a good library called PubSub client, which is providing all necessary features that we need to have if we want to connect our Arduino device to MQTT. And also we have here a library for DHT. As I mentioned, we will also try to read data from battery, because we will send to MQTT broker also status about battery. So we need to provide a pin from which we can read battery level status. We will also use through MQTT, we will have a few examples how to control something. So we will try to control a LED diode, and this diode will be connected to pin number 6. DHT pin, it's actually the pin number to which we connected a DHT sensor. And DHT sensor has actually two types, DHT11, DHT22, and in our case we will use for examples that we have here DHT11. You will need also to provide, the credentials for your Wi-Fi network. So usually it's a Wi-Fi name, and it's also the password which you need to use. The next thing which we have here is that we need to provide an address of the MQTT broker. You need to specify on which port it's running, and we need to use some credentials for MQTT broker as well, because sometimes we, for example, don't want to have, for example, for a device access to topics from other applications or from other devices. So what we can do in MQTT broker is that we can create a user account, and this user account is, for example, limiting the scope to which topics you can have access. For example, the most used open source MQTT broker, it's a Mosquito. And this Mosquito has a quite simple configuration of user access, where you can, in a configuration file, specify, for example, that a particular user account can access only particular, for example, topics. Below, what you can see are actually the topics which will be used in our application. The first topic called sensor DHT data. It's used for actually data that we get from the sensor, like humidity, temperature. Another topic is for sending or for providing actually the status about device, like a battery level. And this last topic, it's what we will use for remote control of the LED diode on our device. Again, if we return back to our slides, so here you can actually you can see LED diode that we will remotely control through MQTT. Here we can see two variables. One of them called HTTP client is actually responsible for communication with Wi-Fi network, and the other one called MQTT client, that's actually what we use for communication with our MQTT broker. All data that we are sending from our Arduino node, we send in time interval of 15 seconds. It can be changed, it depends on your needs. So in this demo, we will use, interval of 15 seconds to send data. As you know, the Arduino has a method called a setup, which is called only once, usually when you start an Arduino device, and it allows you to configure, for example, your application to set up communication, for example, with Wi-Fi, with serial ports, and so on. In method setup serial ports, we will set up a serial communication, which we use, for example, for debugging, for logging. I will show you shortly. Setup Wi-Fi, it's a method actually where we will make a connection to our local access point and get access to the network. Here you can see that I configure MQTT client, which broker it should use and which port it should use for connection. The callback is actually the way how we can receive, for example, a command from MQTT, and this command we will use later on for taking some action on Arduino device. This one, it's for configuration of DHT sensor. So before we can get any data from DHT sensor, so we need to make an initialization of the library for DHT. We need also set that pin number 6, where is connected our LED diode. It's an output. It means that we will use it, to store, for example, logical value 1 or logical value 0. And the last thing which we need to do in a setup method is actually to set analog read resolution. And it's because the pin which we are using for reading of battery level, it's an analog pin. The microcontroller usually has analog and digital pins. Analog pin, it means that you can store their values which are corresponding voltage, for example, and the digital value, it's like only a logical 0 or a logical 1. For example, in the case that you want to start engine, you can have something like a logical 1. Stop engine, it can be logical 0, let's say. By default, most of the Arduino devices, it's using 10 bits, like 1024 bits for conversion from analog to digital. And here for Adafruit Feather M0, we are using 4096 bits, which is a 12 bits analog read resolution here. The next method, as I mentioned, it's about configuration of the serial port. We use it only for storing of or for some debugging data in serial monitor, which I will show you later on. This method called setup Wi-Fi, that's what we use for configuration of Wi-Fi. Before we can, make any connection, so we need to actually say on which pins is connected Wi-Fi module. As you can see here, so Adafruit Feather has a Wi-Fi module, and if you know Adafruit Feather M0, it's actually a collection of various microcontrollers with various types of connectivity like Wi-Fi, LoRa, Bluetooth, and others. And usually, if you want to use it, so you need to specify on which port numbers, for example, the Wi-Fi is connected. So that's the reason why we have it here. Adafruit, it's using chip called AT-Win-C1500 as a Wi-Fi. Here we are just checking if we have a Wi-Fi shield. If not, so the application actually will not continue. Otherwise, we are trying to make a connection to our Wi-Fi network. Wi-Fi SSID is actually the name of your Wi-Fi, and this is the password which we are using for for connection there. And if the connection to Wi-Fi is successful, so we will print information about Wi-Fi network, and you will see there information like a IP address which you received from access point. You can see there MAC address of your device, and you can see, for example, signal strength and also which firmware version is it using. So that's what we do with connection or configuration of the Wi-Fi module. The loop method, it's something what in Arduino we have for like an infinitive loop where you have your main code, and this code it's running in infinitive loop and is doing something. For example, in our case, we are using this loop method to read data from a sensor and to send it through MQTT. Because MQTT require to not only it's not only about sending data, but it's also about receiving data, and we need also keep a connection alive to MQTT broker. So actually, in each cycle of loop method, we need to make sure that we are still connected to MQTT broker. If we are not connected, so we need to reconnect there. And if we are connected, so we need to call this loop method, which is actually, keeping the connection to MQTT broker alive. And also it's checking there, for example, if there is incoming command like a message that you can receive from a topic. And that's why we have here this MQTT client loop. It's basically keeping MQTT library connected to our broker. Collect data. So this method, it's something what we use for reading of data from a sensor and sending this data back to MQTT broker. Below you can see our reconnect method, and you can see here that we are trying in a cycle connect to MQTT broker. For a connection to MQTT broker, we actually need to provide a client ID. This client ID, it's a string which has to be unique, and it has to be unique in a MQTT broker. Usually, what we do is that we are using a MAC address of a device to make sure that our client ID is a unique and there will not be any collision. Otherwise, the device could have a problem with connection to server. I mean to MQTT broker. And as you know, MAC address, it's something but it's unique, so we can use it as a unique identification of the client which is connecting to a MQTT broker. The next parameter which we have here is a username and also the password which we need to provide. If everything goes well, so we can display a message in the console that we are connected, and we will subscribe to topic which we are using for receiving, for example, a command that will turn off or turn on a LED diode. If the connection was not successful, so what we can do is that we will, log this error message, and we will wait 5 seconds, and after that we will try to make a reconnection. Sometimes what can connect is that, for example, what can happen is that MQTT broker, for example, can be unreachable for a while. For example, the server where we have a MQTT broker, it's in maintenance mode. We are rebooting that machine and so on. And because in our case, each loop cycle, we are trying to make sure that there is a connection to MQTT broker, and if we detect that it's not connected, for example, because we are having MQTT broker in maintenance mode or it's restarting, so this reconnect will help us, to keep the connection alive and try to reconnect if the server is unavailable for a while, for example, which is a quite important thing. If you have a sensor which you deploy somewhere in a remote location and now it stopped to work, so it could be not good, that you have to go there and manually, for example, restart the device or something else just to get it to work. So that's usually what we need to think when we design a firmware for our application, that there should be implemented the functionality which is trying to do a reconnection if the server where we are sending data or which we are using also for receiving of commands for some automatization things, if it's still available for connection, and if not, we should try to restore the connection. Here we have a method called getMACaddress. Basically, this is just only a way how I convert an array with MAC address data to a string. If I return back to our method called print Wi-Fi status, so you can see that I read this MAC address information and store it in array called a MAC, and I'm using that array later on for conversion of the MAC address to a string. Another method which we have here is collect data. This method is responsible for reading data from DHT sensor and for reading of device status. Every time when we enter this method, so we are checking if there is more than 15 seconds from last time we collected data. If yes, so we go inside, and now we are reading data from a DHT sensor, and if there are some data, so we use method called sendData, which has two arguments. The first argument is basically the name of topic where we want to send data, and data itself, it contains the payload, which is a JSON structure. In MQTT, we don't have to send only a JSON structure as a payload for a topic. We can basically send any string. And as you will see later in one of my examples, so for example, for commands, I'm not using the JSON. I'm using just, a number, for example, like a 0 to take a action like a stop something, or 0 to start action. And the second part here is actually about reading of status of the battery status, and we are sending this information to another topic. Again, if I will return back to the list of our topics, so we can see that the first topic it's for data from DHT. The second one it's for status of a device, and the last one it's just only for taking a control for like an example for having a command on a device and taking action for that. Okay, so let's return back to collect data method. So as I mentioned, we are reading data from a DHT sensor and sending this back to MQTT broker. And here we are reading data like a status, device status, and sending it as well to MQTT broker, but to another topic. If you will look closely at the method read data, so you can see that basically we are calling the methods from the HT library. The first one is a read humidity, the other one is read temperature. We can by default read temperature, return temperature in Celsius. If we want to get the temperature in Fahrenheit, so we just need to use an argument, a set argument of a read temperature to true of this method. A good thing is also to check, if we are getting any data for humidity, temperature, and temperature in Fahrenheit, because sometimes what can happen is that, for example, the HT sensor can be, for example, not working, incorrectly connected. So we just need to know what's happened if the sensor is available or not. We can also get from the DHT library a heat index, and that we are sending in a JSON structure to server as well. And here you can see how we are actually creating the JSON structure. It's a simple replacement of a string by variables. And the method read data, it's returning that JSON structure, which we are sending later here through MQTT to our backends. Another method is read status, which is actually reading the status of the battery. On Adafruit Feather M0, you can actually read the battery level from pin number A7. It's this variable BAT pin. And we need to do some calculations, to get also correct voltage of the battery. And the battery which we can connect to Adafruit Feather M0, it's a battery with 3.7 or 4.2 voltage. And basically, if you want to know the percentage, for example, how many percentage of the voltage on battery we have, so we can use this formula. If the voltage is below 3.2, so the battery it's really almost empty, because if the level is below 3.1, so the microcontroller it's stopped to operate and the device is not working. Basically, we are good if the voltage is more than 3.5. If we get less than 3.5, it's not good. And here again we have a JSON structure as a string, and we use simple string replace operations, to add their values from our variables. And that's it. Now we can take a look at send data method, where you can see basically that we are checking if we have empty string. If yes, so we just skip this method. Otherwise, we are using MQTT client library, and there is a method called publish, and the publish has two arguments. The first argument is name of the topic where we want to send data, and the second argument is a payload where we want to send data. And because every time when we send data, so we need to update this variable, which we use, to checking if we have, if it's another 15 seconds, and we can read new data from a sensor. And the last method which we have here, it's actually a method called a callback. It has we have a three arguments, and the first one it's a topic from which we received a message. The payload, it's a message that was sent to this particular topic, and size of data for that payload. The callback, it's actually the way how the device can receive, for example, a command for controlling. And here we just only look to a console, that we received a command for a particular topic. We will display what payload it was. And here we are checking if the payload was for our topic called /sensor/DHT/let. And if yes, so we will just check, if the value is greater than 0. So it means that we want to turn on the LED diode. Otherwise, it's turn off for the LED diode. High, it's like a value 0. It's a logical 1, and low, it's a 0, which means logical 0. Yeah, and that's it. So what we can do now is that we can try to compile this application, and let's start a demo. So as you know, in Arduino, you can actually compile the code by this button. So let's try it. And we can see the compilation is done, no error. The next thing what we should to do is to deploy this firmware to a device. So before we will do this, so we need to make sure that we have a board for Adafruit Feather at 0. We need also to make sure that we have connected correct port, because these microcontrollers, like from Adafruit, ESP8266 and others, they are using the USB serial line for communication, like for upload, for example, of a new firmware. So what you need to do in Arduino editor is to make sure that you have a correct port which you are using for uploading of the code to a microcontroller. So let's upload the code there. But before I will do it, so I just need to provide here correct credentials that we have for our local Wi-Fi. Okay, so it's Uploading the code, we can see the done uploading, and what we can do now is that we can check the console. Uh, we have something like a serial console where you can see actually the output from the serial console. If you remember, so we had that method serial ports, which allow us to configure the serial port for communication. It's not only for uploading of the code, it's also can be used, for for um, for example, logging. Sorry. Yeah. Here you can see that we have connected Wi-Fi. We can see the name of the Wi-Fi. We can see the IP address, which was assigned to this Arduino device. We can see also our MAC address, which we have, and other information. The next step here is that we are trying to connect to our MQTT broker, and if everything works, so we can see we're connected. And now each 15 seconds we are sending this data to our MQTT broker. You can see data which is containing data from a DHT sensor, and the status it's having the it's providing the status of the device, like level of the battery. Okay, so next step is that we should try to check if we can see this data really on MQTT broker. So what we can do is that we can use the client. I mentioned that we have that we have there exist several implementation of the MQTT broker and of MQTT client. The most used by makers, by IoT community is a Mosquito, which it's open source. It's providing not only that broker, but it's also providing a client which you can install on your machine, and you can use it for accessing of data. Usually, before you can read any data, so you need to yes, and command mosquito underscore sub. It's like a subscriber. So basically, you want to subscribe to a topic where we are sending data from our Arduino device. And the first thing what we need to do before we can get any data, so we need to provide an address of the MQTT broker to which we want to connect. Option minus dash H, it's like a host. This say on which port number is MQTT broker running. This is the user account which we are using for accessing of MQTT broker, the password, and finally this is the name of topic. So let's try start this. What we can see. If you will use this one, so basically you should see all topics that we have on that MQTT broker. Now you can see that we have there data from our sensor. So we can see data from DHT, and we can see also battery status. If we want to, for example, see only, for example, device status, so we can specify from which topic we want to get the data. And yeah, this one. And every time when Arduino device sent any payload to /sensor/DHT/status topic, so we can see it here. Yes, that's what you can see right now. The next thing is that we can check, for example, only data from a DHT sensor. So let's try it. As you can see now, we are using a different topic. It's a /sensor/DHT/data. And you can see that we have there the humidity and the temperature from our sensor. And that's basically the same thing which we can see also in this console that we are sending from Arduino device to our MQTT broker. So that's the way how we can, for example, read data from MQTT broker. Now let's try to send something back to a device. Let's call it a command. If we want to send something to a topic on MQTT broker, so we need to use a different command. In this case, it's a mosquito underscore pub, like a publisher. And again, we have to provide to which MQTT broker we want to connect, on which port number it's running, the credentials, and now the topic. We have this topic for receiving of the commands, and finally it's a message. So this is a message which it's a string. So here we can have, for example, a JSON structure, or it can be only like this. And now let's check the Arduino. And yeah, as you can see, so we received actually this value 01, and that's how we can, for example, do something on a device. Let's try to send, for example, JSON back to this device. Okay, it should be this one. Yeah, but now you can see that I don't have, or I cannot see that I received a message. The reason for this is that we have here a new topic called /demo/messages. And because my Arduino code or my Arduino application, it's not subscribed to this topic, so I don't see anything. But if we want to, so it's quite simple. What we need to do is that we need to go to our method reconnect. And here you can see that we have actually calling of method subscribe from MQTT client library. And if we will add here the other line, and we will use this name. and we will compile and deploy new code back to our Arduino device. So we will see that we sent a message to a topic/demo/messages. We will see that this Arduino device has received it. Okay, so we are now connected, and let's try to run this command again. And as you can see, we have received a message hello world from topic/demo/messages. And by this way, that's how you can basically work with commands, and how you can send, for example, action with some parameters that can do something. Let's try, for example, send there a JSON structure. You can have something like, for example, command. And now I received from this topic a JSON. And if you will implement a processing of the JSON, so you can use also this JSON structure for more complex use cases. Sometimes, you want to send a command that, for example, will configure something, change some settings, or do multiple things. And for this, it's good to use JSON. You can, of course, use something else. If, for example, you don't want to use a JSON, because you will need to implement actually the JSON parsing. And if you want to, for example, send something more simple, so what we can do is, for example, that you can have, for example, this one, like data are, that you have actually key value parameters, and each parameter it's split by comma. That's, for example, another case. Or you can use totally binary thing. That, for example, let's try to send it. And again, you can see we have it here. Or you can have a totally binary thing, for example, that you will know that the first byte, it's, for example, command, and that command has only one argument, like a one param, and it's another byte, so you can do this. And use it for processing. So there exist many ways how you can actually store data for a command that you are sending through MQTT to a device. For example, sometimes you have really low devices, I mean not much memory, and for example limited storage, and for example anything like another library which allow you to parse JSON structure can, for example, increase the requirements for memory or storage where you have your firmware. So sending alternative way for the commands, like for example these parameters or this binary thing can be the option as well. Okay, that's the thing about the Arduino, how we actually can create Arduino code sending data through MQTT to MQTT broker, how we can actually receive data back on Arduino device through MQTT. The next part will be about creating of a Node.js application, which will read data from MQTT broker and store this data in Influx database, and later on Influx database will be used as a data source for a data visualization in Grafana. But before we will move there, do you have any questions so far about this Arduino part? Okay, so now let's start with Node.js. The Node.js, it's JavaScript framework that allow you to run application. Maybe most of you know the JavaScript from a web browser, where you can use JavaScript, for example, for some UI stuff. But Node.js, it's a case of a JavaScript implementation when you can run a complete application in JavaScript. It can be, for example, a server-side application, or it can be even the front-end application that doesn't require to have another server, like for example Apache, to run it. And here we are using the Node.js as a simple console application that connect to MQTT, get data, and connect to Influx database to store data. So let's take a look at first on Node.js application. So at first, what we need to have in our Node.js application is actually that we need to add there, or actually we need to import two libraries. The first one, it's MQTT, which is a client library allowing us connect to MQTT broker and read data. Influx, it's another library which we can use for reading and writing data to Influx database. Here we have credentials that we will use for authorization to our MQTT broker. Here we can see the connection configuration of Influx client. Our Influx database is using this host name. It's running on this port number. All those components like Influx database, Grafana, or this MQTT broker, this everything will run as a Docker container, so you can run it on your local environment and to use it for testing and development. Database where we will store all data, like our measurements. It's called IoT monitoring, and the credentials that we will use for connection to Influx database, it's like a username root and password root. It's a default which you will have when you will install and configure the Influx. This method, it's checking if there exists IoT monitoring database already. If not, so this part of the code will create it, and we can use it for later on for storing of our measurements. The other one is a method which I have here, and this method basically write the points. The point, it's actually something like a row that we add to a measurement. Measurement, it's like in a SQL database, a table. And we have here a measurement for temperature. We have measurement for humidity, and the values are actually float numbers that we are getting from Arduino, from the HD sensor, and Arduino device is sending that to MQTT. Below we have configuration of the MQTT client. So what you can see here is the list of topics where we want to subscribe this MQTT client. MQTT Bridge is reading data from topics for data and status of the DHT sensor. MQTT options, that there you can set up a unique client ID. If you remember in the DHT, in that Arduino code, we had to set a unique ID as well. We were using their MAC address of that Arduino device because that's what we need for this MQTT broker. Each client needs to have a unique ID. Also, the credentials we have there, which we will use for connection to a MQTT broker. Here you can see the address of MQTT broker, the port number where we are connecting, the MQTT options. That's what we are using for credentials and client ID. And here you can see actually the topics to which we are subscribing. And that's almost done. Just two methods which we have here. We need to actually set or we need to handle incoming messages to our topics. And you know, every time when we received a message like a JSON structure to one of our topics, so we are logging to which topic it was and which payload we had there. And if it's a topic with sensor data, so basically we are writing this data to Influx database. At this moment, we are not writing the status, which contain the battery level, just only data from sensor. And that's it. So that's basically that Node.js application. So let's try to run it. I will just comment the part for Influx database because I just want to show you how it works with this MQTT client before we will do any integration with InfluxDB or with Grafana. To run this application, you just need to start Node and start.js. You can see that MQTT Bridge started. And yes, we can see that we have received data from for our topic. We can see the payload here, and this data are data that we are forwarding to InfluxDB, but at this moment it just only log that structure to console and does nothing. And here we can see status from the battery. Yeah, so the application is working. It's reading data from MQTT, and the next step is to write those data in Influx database. So I will comment out this part for Influx client. And because we will need to run on our machine Influx database and Grafana, so I will need to run those two components as Docker containers. If you attended one of our previous workshops, so we look at the Docker there more in detail. Basically, Docker, it's the way how you can run applications in isolated environment on your machine, and you can run this application just by a few lines of configuration in a few lines of configuration settings, or by a command, and you don't need to install it. You don't need to do any complex configuration. So for development and testing, that Docker, it's a quite great thing. But before we will look at that Docker thing, I mean how to start a Docker container with Grafana or with Influx database. So we need actually create a Docker for MQTT Bridge as well. Each Docker application needs to have its own settings and configuration. That's what we have in the file called a Docker file. So take a look at this. In this compose file or Docker file, sorry, it's a Docker file. You can see, like for example, there exist thousands and thousands of another Docker images that, for example, have configured and installed components that you may need. In our case, we just need to actually extend a Docker container or Docker image which has Node.js installed or already, and we just need to add on the top of this Docker image our application. So by this line, we say that we want to create a Docker image which it's based on the Docker image for Node.js. We are using Node.js version 10. By this command, we actually create a folder called /opt/node-app, where we will have our Node.js application. We just need to set the work directory, and we need also to set that that application will run under a Node.js user account. We need to copy a configuration file called package.json. Basically, this package.json contains a list of all libraries for our Node.js application that has to be installed. And when you run npm install, so basically it reads data from a package.json, and it install the necessary libraries, for example, library for MQTT or library for Influx database. The other thing that we need to do is that we need to copy to this Docker image two JavaScripts. The first one, it's JavaScript that we are using for starting our Node.js application, and the second one, it's the Node.js application itself. And this command just say when you start that, because before you can create a Docker container, you need to have a Docker image. That's the reason of this Docker file, to create a Docker image with Node.js and our application for MQTT Bridge. And when you create a container from this Docker image, so Docker will take this command and run it. And if you remember, so previously we used a command called node start.js to start our MQTT bridge. And that's the thing which we are doing by this command here. And that's it. Let's take a look also at package.json, how it looks. You can see that package.json, it's a simple JSON structure where you have the name of your application, you have their version, you have their description, you have their the name of the application that it starts. You can see here dependencies like libraries and other things. Okay. The next step is that we need to build this MQTT bridge as a Docker image. For this, we are using a script called run.sh. And run.sh script, actually it does two things. At this line, it's a building our MQTT bridge. It means that it creates a Docker image that we can later on start and use for our demo. And this second command, it actually starts something like a template that we call a Docker Compose file. And in this file, we have actually a list of services like Docker images that we want to start. And we will have there a list of images like for InfluxDB, Grafana, and Node.js application, which is our MQTT bridge. For each, or actually for InfluxDB and Grafana, we will need to have a folder where Grafana will store their data and configuration settings, and the same for InfluxDB. Before I will run this script, so let's take a look at the Docker Compose file. And that Docker Compose file, as I mentioned, it's some kind of the template where you can have a list of services that you want to run on your machine. So we want to run the InfluxDB, we want to run the Grafana, and we want to run our MQTT bridge. For each service, you need to provide a unique name like a Grafana or, for example, MQTT bridge. You need also to specify from which Docker image this service should be created, and it's like a name of Docker image and its version. You can also provide a name to each service, like a container name that you can later on use for communication between all these services. So it's mean, for example, if in Grafana I want to connect to InfluxDB, so I need to provide, the something like a host names, because these services are running in a virtual Docker network environment, which is isolated, and I cannot reach it simply from a host machine. If you want to reach or access the particular container from your host machine, so what you can do is that you can expose the port. For example, InfluxDB is using port 8086. And if you want to access it on your local host, or on your host machine, you can expose this internal port to your host machine. You can also provide a persistent storage for data of your Docker container, like InfluxDB, because when you, for example, update or let's say when you remove this container, so it basically remove also all data which you have here, and InfluxDB it's storing its data in a folder /var/lib/InfluxDB. If you want to have it, on your machine, I mean, you want to have a persistent storage, so you need to mount this folder, for example, to folder on your host. Similar thing we have for a Grafana. We just have here one thing more, which say that Grafana depends on Influx database, because Grafana actually is reading data from Influx database, so there is a dependency, and InfluxDB should be started before the Grafana starts. Grafana use port number 3000. So if you want to access this data, so we need to use on our host machine, so we need to use, or actually we need to expose port 3000 to the host. Also, we want to store all configuration data and other data from that Docker container on our host machine, so we need a persistent storage. And now our MQTT bridge, again, it also depends on Influx database, because we are storing actually data in Influx database. So before MQTT bridge can be started, Influx database has to be running. So let's try now run this Docker containers. So I will run the script .sh. But before I will do it, so you need just to provide, you need to set the permission to execute for this script. So that's what you do by chmod +x. And if you will check now that script, so you can see that the script can be run by a user. So run it, you can see that now it's building that MQTT bridge. It's also starting the Influx database, Grafana. It's also starting MQTT bridge. And now what we can do is that we can check the list of Docker containers that are running on our machine. You can see that we have there our MQTT bridge. You can see that we have there our Grafana, and that we have there our Influx database. Here you can see also that Grafana is accessible on port number 3000. Influx database it's accessible on port number 8086. The next step, what we need to do, is to make sure that our MQTT bridge is working correctly, that it's reading data and it's storing data to Influx database. So we can run this command, which is actually reading log file from a Docker container called MQTT bridge. So again, you will start the command docker container logs -f. It say that it's listening for new changes, and if there is new change, so it update your screen. And we can see that the code should be working correctly, because we can see that we are receiving device status. We are receiving actually the measurement from a DHT sensor. Before we will check if this data we can see in Grafana. So I will do one thing, because I just realized that I didn't uncomment it writing to Influx database. If you remember previously, we tried to run this Node.js application just like a MQTT client, and we were just only displaying data in console without any integration with MQTT. Now to get it to work, so we needed to uncomment method write data to Influx database. So that's it. Now I will need again compile that Docker image because I changed the code. So I need to build a new version of the MQTT bridge. So I will run again a script run.sh, and it's again building that MQTT bridge. It's starting Influx database, Grafana, and MQTT bridge. But you can see that there is no change for Influx database and Grafana. So basically, these two containers was not started. They just are running, and you can see that they are running for a while. Only MQTT bridge was started because basically we changed their code. We created a new version of this Docker image. So that's the reason why we have here just only a few seconds it's running. So let's take a look at log file again, if everything is working correctly. Yes, and we can see that the screen is updating. The next step, what we could do is also that we can, for example, make sure that Influx database is running correctly. So we can use the same command like docker container logs -f InfluxDB, and we can see the log file from Influx database. We can see that every time that we store something in MQTT bridge to Influx database, so we can see that it received that request, because Influx database actually it uses a REST API for communication, and our Node.js application is using REST API for connecting to Influx database and sending data. Data are sent as a JSON structure between these two components. Okay, so it seems that we have something now in Influx database. So the next step is just to connect to Grafana. And as I mentioned, Grafana is running on port number 3000. So we can use on our machine a local host and port number 3000. By default, the Grafana has a user ID admin and the password it's admin as well. For the first time, it asks us, if we want to change the password. I think we can skip it for now, and we are here. Before we can, create any dashboard and we can do any other stuff. So what we need to do is that we need to configure a data source. Data source, it's actually the way how the Grafana can access data for example, a data visualization. We have multiple of data sources that we can use for accessing of various type of data measurements. It's not only for IoT. The Grafana can be used, for example, for infrastructure, IT infrastructure monitoring. It's like Prometheus, for example. It's you can monitor a database, read data from database, and so on. In our case, we need to configure Influx database, so that's what we will choose here. So at first, we need to provide actually at which address the Influx database is running. The next step is to specify to which database we want to connect, and the credentials. So in our case, the credentials are root and root. Like user is root, password is root. Below you can just find useful information. That if you are using an account for accessing data from database, you should use something that is just only for reading of data, something that is more better configured. You shouldn't use root for production use, but this is just a demo, so we are fine with this. Before we will, we should also test the connection. That's what we can do by this button, save and test. And as you can see, the Grafana was able to successfully connect to Influx database. So that's it. And as you can see, we have here a configured data source. You can see that I use the host name called InfluxDB. The reason for that is that, as I mentioned, all our Docker containers are running in a Docker virtual network environment, and each container has a host name, and you can access those containers by their host name. So Influx, the container with Influx database has this one host name, and Grafana has, for example, the Grafana. MQTT Bridge has, for example, MQTT Bridge, and so on. So let's now create a dashboard. We want to create a chart dashboard. So at first for temperature. At first we need to choose from which data source we want to get the data. The next step is from which measurement. And as I said before, the measurement, it's like a table in SQL databases. Yes, you can now see that we have here something. Yep, this one. Let's use better name. Temperature. Okay. Come back. It's temperature. Now we can add another gadget, another panel actually, and it can be for a humidity. Again, we need a data source for Influx database. And we shouldn't forget to save this dashboard, otherwise we will lose all our settings. So let's call it IoT monitoring. And that's it. So as you can see, what we did so far, so we basically we created Wi-Fi node with a DHT sensor. We connected this Wi-Fi node to an MQTT broker. We built a Node.js application called MQTT Bridge, reading data from broker and storing in Influx database, and we use a Grafana for a data visualization. We tried also send back a command to this Arduino device to, for example, take action. We also try to read a battery level, like a part of a device status. And we also tried to build a Docker image with our MQTT Bridge application. We deployed locally Influx database. We deployed also locally Grafana, and we get this working on our local machine. Do you have any questions? Okay, so that's all for this workshop about MQTT. We will have in other IoT Garage, which should be next weekend, workshop focus on particle boron LTE. So it means that we will show you how you can actually build a sensor connected to LTE-M network, which is available in North America, and you will see how to build a code for particle. It's not difficult. Particle provide a REST API, which is providing also a publisher subscriber concept. We will try, use a particle REST API for remote control and for some automatization things that we can do with particle API. And also we will try some data visualization.
Hi, Thomas. A question, please.
Mm-hmm.
That's a great demo. Thank you very much. What need to be changed in order to connect to Azure IoT Hub as the MQTT endpoint?
Basically, what you need to do, because that library which we have, it's a generic, and you just need to provide the Azure IoT, it's using a secured connection for MQTT. That's something what I actually didn't mention, that in our example we use MQTT without TLS, which is running on port 1883. In the case of this Adafruit Feather M0 Wi-Fi version, you will need to use port 833. And you will need upload, I think, certificate to this Adafruit Feather device. But the rest should be the same, So it's more about configuration of SSL communication, but the way how the library be used, like a subscribing or publishing of a payload, it's remain the same. Just only the way how you will configure a TLS configuration.
Makes sense.
If interested, so maybe I can provide a few I can provide example, because this what I presented here will be available as a part of GitHub repository, so I can add their example also how to connect to Microsoft Azure with TLS.
Great, that would be awesome.
Yes.
Because Azure IoT and AWS IoT are kind of the two most popular cloud IoTs, right? And so I think there would be a lot of interest in that.
Yeah. Okay. So
thank you very much.
Welcome. Okay. So yeah, and as I mentioned, next IoT Garage we will focus on particle boron LTE. And we will try this time also more look at Grafana, because so far it was about simple charts showing you humidity, temperature. But what I would like to do is that we will use more complex dashboard with more data, battery level, for example, what we will have there, and some other things. Okay, so that's all from my side. In few days, we will share the code, slides, and so on GitHub. And looking forward to see you at our IoT Garage. Thank you.
Thanks. Bye.
Bye.